Okay, started the recording a little bit late, but we kind of reviewed and talked about the axis of symmetry. The axis of symmetry is the line that's an imaginary line that splits that parabola into two identical parts. Parabolas are symmetrical about the axis of symmetry. They can open up or down, but not left or right. I think this is what you're writing in your notes. And it has a vertex. And that vertex is a maximum or a minimum output. It's not, can't be both. Okay? So we're going to learn more about the axis of symmetry now. And we talked about it before we started the recording. We did some things on the board. So the axis of symmetry is an imaginary vertical line through the vertex of the parabola. It can't be left or right. It's got to be up and down. It's represented with a dotted line when graphing. But remember, it's not actually part of the graph. It's not actually part of the parabola. The axis of symmetry is the x-coordinate of the vertex. This is important. We're going to repeat this a couple of times throughout the day. The axis of symmetry is the x-coordinate in the ordered pair. Remember, the vertex is just a point on the parabola where it turns. And then once we find the axis of symmetry, now we'll know the coordinates, the x-coordinates of the vertex. The axis of symmetry can be used to graph mirror points. That makes graphing parabolas easier, a little less work. And there is a formula for the axis of symmetry. I'm going to actually move that. Let's move that negative sign up. You could leave it there, but I think it's more user-friendly to put it in the top. So we're going to put x equals negative b, and that really means the opposite of b. If b is positive, then it'll be negative b. But if b happens to be a negative number, the opposite would be a positive number. So x equals the opposite of b over 2a, in case that was confusing. We learned that, and used in our homework last couple of days, if you see a quadratic equation in standard form, then the coefficient on a is, on x squared is the a, the coefficient on the x term is the b, and the constant is the c, and we also learned, you don't have a line to this because you're going to write that to the right, we learned the c is the y-intercept. This is review, I know. But the y-intercept is one of the points we're always going to plot when we're graphing a parabola. On the ones we graphed yesterday, the y-intercept was also the vertex, but it's not always that way. The ones we're going to do today won't always be that way. And that's what we're working towards today. We're working on graphing a little bit more accurately a parabola using mirror points, axis of symmetry. Also, we didn't know how to find the vertex the last couple of days unless we just kind of trial and error with the t-table. But now we're going to be able to find the vertex algebraically. In other words, we won't need the graph, we won't need a t-table to find the vertex. So the steps, now yours is wrong, so you're going to fix this. Yours says steps to finding the vertex. It should say axis of symmetry. So fix that, scratch out vertex. Also you can use, I'm going to be using A, O, S for axis of symmetry because that's a lot. A for axis, O for odd, S for symmetry. But it should say steps to finding the axis of symmetry here, not the vertex. Did you correct that? My mistake. Here, stretch that. Right, axis of symmetry. you also should have C is the y intercept there. Yes. So to find the axis of symmetry, the first thing you're going to do is you're just going to find A, B, and C, and we've been doing that. So you're going to determine the A, B, and C of the quadratic equation by writing it in standard form. And most of yours are going to be in standard form already, but if you have quadratic equations that aren't in standard form, that means, remember, you get everything by itself, all the x terms and the constants by themselves, the y term on the other side. Right, so x squared term, and constant have to be on one side, the y has to be on another side. If the equation is written in function form, it's already in standard form, that's the only way you can write a quadratic equation as a function is if it's in standard form. We just replace the y with the f of x. Once we found our A, B, and C, then we just plug them into the axis of symmetry formula. And we wrote that up above. While I'm thinking about it, I want you to write that formula on the top of your homework. I'll be looking for that when I grade them. So you're on the top of your worksheet. AOS is x equals opposite of b divided by 2a. We're writing that on the top of your homework assignment. X equals the opposite of b divided by 2a. And now I'm going to do a couple of examples of finding the axis of symmetry. So if we find the axis of symmetry, remember, we'll know that that line is going to go through the vertex. We won't know exactly the point, but we'll know the x-coordinate of that point. We'll know it's somewhere on that imaginary line. So let's write down example 1. Example 1 is y equals negative x squared plus 4x minus 6. Can you guys see that? Should I rewrite it bigger above it? Y equals negative x squared plus 4x minus 6. Once you have that written down, go ahead and determine what is the A, what is the B, what is the C. Write it in your notes, and you should be using pencil because you know, even if you've never made mistakes, you know I do, and you may have to erase for me sometimes. What is the A, what is the B, and what is the C? What's the A? Do you know, Brandon? That's the trickiest one here. Danielle? Is it negative x? No. Negative 1, very good. Negative 1. Remember, if you don't see that there, that's a 1. What's the B, Peyton? Okay, so look at this little box in your notes. See where it kind of tells you? Does that make sense? So the A is with the x squared. So in the example, the A is 1, right? The B is with the x. So in the example, the B is 9, because this 9 is with the x. Okay, so what's your B here? What's with the x? And what's the constant? What's the C, Gladys? Negative 6, that's right. So we determine the A, B, and C to find the axis of symmetry. We're going to plug into the formula. X equals the opposite of B divided by 2A. So x equals the opposite of B, and I'm writing that kind of weird because if we don't write it that way every time, you're going to mess it up. If B were a negative number, you have to take the opposite of that, right? So always let's write it that way first, divided by 2, so 2 is always a factor in the bottom, and then times A, and our A is negative 1 here. So that's negative 4 divided by negative 2, and so the axis of symmetry is a positive 2. Now remember, you cannot write just 2, because the axis of symmetry is a line. The way to write the equation So if you are asked for the axis of symmetry and you say 2 here, you will have done all the work and you will get it wrong. Okay, the axis of symmetry, you have to know that that is the equation of a line. Remember, a y-only line is a horizontal, right? And x-only line is always a vertical line. So the axis of symmetry here, so that is your answer. Any questions? Okay, so let's go ahead and write example 2. I'll write a little bigger if you need it. Y equals x squared plus 4x plus 5. And then go ahead and find the a, the b, and the c there. Go ahead and find the a, the b, and the c there. So what's your A, Jeremiah?
1.
Perfect. What's your B, Jacoy?
4.
Good. What's your C, Brandon? Nice. So once we do that, all we have left to do is to plug it into the axis of symmetry formula. So that's the axis of symmetry formula. So x equals the opposite of 4 again, divided by 2 times, a is positive 1 now, so that's going to be negative 4 divided by 2. So the axis of symmetry of this equation is x equals negative 2. Remember, that this means it's a vertical line through negative 2 on the x-axis. So, real quick up here on the board, the difference between those two. The first one was positive 2, so that's positive 2 on the x-axis, right? To the right. So the axis of symmetry, we would graph in a dotted line through 2 on the x-axis. The axis of symmetry on example 2 is through negative 2. So the x equals negative 2. So it's a vertical line through negative 2 on the x-axis. Okay? Any questions? Okay, so now we need this in order to be able to find the equation, or the vertex of the quadratic equation or of the parabola without looking at a graph. So if we can see the graph of the parabola, we can pick out the vertex. We can pick the turning point in the parabola. But if we don't, then algebraically we need to be able to find the axis of symmetry. That's part of the process of finding the vertex. Okay. We know that the vertex is the maximum or minimum point on the parabola, and we should know that it's represented as an ordered pair. We worked with that the last couple days. Talked about it anyway. So the axis of symmetry, we've written it once, it's important, so we're writing it again, is the x-coordinate of the vertex. So x-coordinate, and then we have to find the y-coordinate. Once we know what the axis of symmetry is, all we have to do is find the y-coordinate, and then we will have the ordered pair for the vertex. So, to find the vertex, and this is when you're only given the equation, not a graph, because if you're given the graph, it's easy to look on there and see. We're going to find the AOS. Remember, the AOS is the axis of symmetry. And then we're going to plug that AOS into the original equation. And then we're going to make sure we write that ordered pair. couple examples of finding the vertex from the equation of a quadratic formula. These directions say find the equation of the axis of symmetry and the coordinates of the vertex. They may not always ask you that way. It's almost like they're giving you a hint. Typically, they're going to ask you, what is the axis of symmetry? You have to know that it's an x equals equation, right? If it asks you the vertex, you have to know that you have to find the axis of symmetry first. Okay? But these directions give you a little bit of a hint. So for example 3, in case you can't read them or write a little bit bigger, it's y equals negative 3x squared plus 12x minus 7. So the first step is to find the axis of symmetry. The first step in finding the axis of symmetry is to find what is equal to, A equals, B equals, and C equals, right? On every problem you do, I should see as part of your work. A equals, B equals, C equals. Okay? So what is A to Corey? So look at the little box in the front page of your notes there. No? So in this one it's 1 because there's nothing with the x squared. But A goes with x squared, B goes with x, and C has no variable. Okay? So for this example, which number is with the x squared? No? What kind of 3? Negative 3, right? So the negative 3 is running in front of x squared, so that's the A. What's the B, Kendall? What's the C, please? Nice. So now, we're going to plug in to find the original equation. So we're going to find the AOS, so now we're going to do x equals the up to the b divided by 2a, x equals, so this is the axis of symmetry we're working on here. Up to the 12 divided by 2 times our a that we've already found. That's negative 12 divided by negative 6. This means our axis of symmetry is 2. The axis of symmetry is not always 2. Ours coincidentally has been 2 twice now, and one time a negative 2. That is, they're all different. They're even fractions and decimals. Negative 12, yeah. The opposite of 12 is negative 12, yeah. So negative 12 divided by negative 6 is a positive 2. So our axis of symmetry is x equals 2. So once we start graphing, we're going to be plotting that imaginary dotted line. Right, but right now they didn't ask us to graph anything. They asked us to find the axis of symmetry, which we just did, and the vertex. Once we're through with the axis of symmetry, remember we have half the vertex already. This goes here. The axis of symmetry is always the x-coordinate of the vertex. So how do we find the y? Well, it says plug the axis of symmetry into the original equation. So here, y equals, instead of x, we're going to write 2. So negative 3 times 2 squared plus 12x, but instead of x, that's times 2, and then minus 7. So y equals negative 12 plus 24 minus 7. So you got straight across in your calculator, you're going to get a positive 5. So our y equals 5. But you can't give me the answer like that. Like the vertex, they ask for the vertex, and you need the ordered pair. We've already got the x-coordinate in there, it just goes in the y. So the vertex is 2, 5. 2, 5. That was there. Axis symmetry is the x. To find the y, we plug into the original equation. Any questions? Good? Alright, so next one looks a little bit different. Oh, no, it doesn't. Oh, yeah, it does. There's only two terms here, and that's okay. In case you can't read it, I'll write it bigger. Y equals negative 6x squared plus 3. What is the a, Arik? What is that c, Naya? 3. What is the b, Jacoy? Very good. There's no middle term, right? The only way to get rid of that middle term is if you multiply the x by 0. So b is 0 if you don't see an x term. So negative 6, 0, and 3. So for finding the axis of symmetry for this equation, x equals, we're using this same formula that we have right here, the opposite of b, or the opposite of 0, divided by 2, always 2, times a. So x equals 0 divided by negative 12, which is 0. So our axis of symmetry is x equals 0. You have to give it as the equation. So the directions asked for the axis of symmetry, and do you need to move back so you can see better? Is that hard for you to look there? I want you to go to 6:15 for today, and then I'll come here. You see your stuff, just move back there, you can get anywhere else. Okay, so axis of symmetry done. Now we need our vertex. Well, we're halfway done with the vertex. What do I mean by we're halfway done with the vertex? 0 for the x. So the axis of symmetry is our x coordinate. How do we find our y coordinate, Fatima? Plug it in. That's right. We'll plug in the x into the original equation. So y equals negative 6, not x squared, but this x, which is 0 squared plus 3. So that's 0 plus 3. So now y is 3. And so that goes here. So the vertex is 0, 3. So those are our answers. Any questions? We got one more page and we have almost not enough time to do it. Okay. If it becomes an emergency, go. Alright, but if not, let's try to hold. Alright, so I'm going to talk about this and uncover to try to kind of make this go a little faster. So now we're talking about graphing a quadratic equation. We kind of really sketched our quadratic equation the last 2 days. They weren't very accurate. To be frank, these are not going to be very accurate either. Solving a quadratic equation and graphing a quadratic equation by hand is just an approximation. It's a very loose sketch. But that's okay. It helps us, actually graphing this quadratic equation helps us understand all the features of the graph of the quadratic equation, all the features of the parabola. So the first thing we're going to do if we're graphing the quadratic function is we're going to identify A, B, and C. We're going to plot points, and we need 5. Right? Our first point is always going to be our y-intercept. The next thing we're going to do is we're going to find our axis of symmetry. We can use that axis of symmetry like we did on this example on the board. If I know that there's a point on this side of the parabola, I don't have to do anything except mirror it over that axis of symmetry. So we're going to be able to use a shortcut of mirroring points that way. We're going to find the vertex and plot the vertex, because remember the vertex ordered here is a point, okay? And typically, we have to find at least, use a t-table and find at least one other point, sometimes 2, right? If the vertex is the y-intercept, then you have to use the t-table for at least one other point. Most of the time, the y-intercept is not the vertex, but all the problems we did the last 2 days, that was the case, so, right? Most of the time, it is not. So, I've kind of talked you through it so we can kind of write a little quicker here. So the first thing we're going to do is we're going to identify ABC, which means everybody needs to have A equals B equals C equals on their paper. The next thing we're going to do is we're going to find the axis of symmetry, which we just did. We're going to use that formula. Remember, it's important, so we keep writing it over and over. Then we're going to find the vertex by plugging the axis of symmetry into the original equation. We just did that. So now we have not plotted any points. We've been gathering information, things that we can use to graph the quadratic equation. But now we're going to plot the y-intercept because we can see that once we have C and the vertex. So we're going to plot the y-intercept and the vertex. So we'll have 2 points on our graph after step 4. The next thing we're going to do is we're going to sketch the axis of symmetry. That means we're going to draw a dotted line through the whatever the number is on the x-axis, remember? Then we're going to plot a point, like we talked about, that mirrors the y-intercept. And that would be mirrors it from the axis of symmetry. So when we say mirrors it, or actually, typically they say about. So let's put about there. That means around it, or in relation to it. So now we have 3 points, because we got y-intercept, a vertex, and the mirrored point of the y-intercept. That's assuming they're not the same thing. Y'all caught up with me? Okay, so now we're going to use the T table to find other points as needed. So we're going to need the as needed. We only need to find 1 point if the vertex is not on the y-axis. We will need to find 2 points if it is, and that means we're going to have a total of at least 5 points. You could do more points if you want, but 5 points is what I'm requiring. So once we find the T table, we find the points, and we're plotting them. So we're plotting the points in the T table, and we're going to mirror points from them. And the very last thing we're going to do is we're going to sketch the parabola. So we are about to do the example at the bottom of the page, and we have 9 minutes to do it. Please do not pack up early. We should be done in 9 minutes. Okay, but it may take the full 9. The other thing I want to tell you before I forget, I've committed to first period to also working one of your homework problems in the video after school, so I'll post. So you have 4 problems in your homework. If you watch the video for 1 and do it with me on there, you'll only have 3. Sound good? Okay. So we are going to get started on our example. The example, okay, here's the example. Y equals negative 2x squared plus 8x minus 10. Once you get it written down, go ahead and find your A, your B, and your C. Yes. negative 2x squared plus 8x minus 10. Anybody tell me, Trinicia, can you tell me what the A, the B, and the C are? Perfect. All right. So, we found our A, B, and C. Now we're going to, we need to identify our y-intercept, and it's not here. So let's talk about, what is our y-intercept? Let's put that somewhere in here, because that's one of the points we're going to be plotting. What's the y-intercept? Zion, negative 10. So we're going to need to make a note of that. Now we're going to find our axis of symmetry. We keep writing this because it's important. The axis of symmetry formula, the opposite of B over 2A. X equals the opposite of B over 2A. Since we've already found our A, our B, and our C, it makes it a lot easier to plug in. So B is the opposite of 8 divided by 2 times A, which is negative 2. So X equals 8 divided by negative 2, which is negative 4. So this is our axis of symmetry, right? This is the equation of the dotted line that we're going to graph to help us mirror points. That splits the parabola into two identical halves. And where does that go? The X. Very good. So that, we've already done half of the vertex once we get the axis of symmetry done. So remember now, to find the y-coordinate of the vertex, because we already have the X, we just plug the X that we put in for our x-coordinate, which is the axis of symmetry, plug it into the original equation. So y equals negative 2 times negative 4 squared plus 8 times negative 4 minus 10. So that's what we're going to do here. So y equals negative 2 times our negative 4 here squared plus 8 times negative 4 minus 10. Yes? Yes? Oh, I forgot to, I didn't plug anything in there, did I? Yes, thank you. Okay, so Akira and, well, Keyshawn found my mistake in Akira is confirming, I forgot to put my denominator, my A in there, I got ahead of myself. So here it's 2 times negative 2, and so it's not negative 4. It is a positive 2. It's negative 8 divided by negative 4 is positive 2. Very good. Once again, our axis of symmetry is 2. I promise they are not always 2. All right. So now we're not plugging in negative 4. See, I told you we're only going to use pencil. If you don't mess up, I will sometimes. So that gets plugged in here. You could do this on the calculator straight across like that. I'm going to simplify it a little bit. Y equals negative 2 times 4, negative 8 plus 16 minus 10. So 8 minus 10 is negative 2. So our y coordinate is negative 2. So 2, negative 2. So we have 2 points that we can graph now and an axis of symmetry. So we're going to scroll down to our graph, or I'm going to scroll down, you're going to go down, and we're going to plot those things. The y-intercept we said was negative 10. So we're going to start there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our axis of symmetry is 2. So So we are going to draw our dotted line through 2. Now, remember, may not be a point on the line, so we don't really want to put a plot there. Just making myself a little mark so I can keep up. And we need a dotted line through 2 on the x-axis. And now we're going to plot our vertex, which is 2, -2. So right 2 and down 2. So now we have 2 points. So now once we have that axis of symmetry drawn, and we have our y-intercept, now this is where we can mirror this point. So this is 1, 2 to the left. We can go 1, 2 to the right. The same height, right? Just 2 on the other side. We've mirrored that point. So 10 down, and then 2 to get the axis of symmetry, 2 to the other side. So we can sketch a parabola now, but our step says you need 5 points. You need 5 points to get credit, okay? There's an infinite number of points in this line. So how do we know what we're going to pick for our other points? Well, we have a pretty good idea of what our parabola is going to look like. I pick an easy number. If we take x as 1, we're going to go over 1. So it's going to be somewhere in here, right? So I'm going to pick, you have a table, your figure looks like that. So you're plugging in 1, right? And now we're going to take the 1, don't pack up, we'll be done in just a second. Don't pack up. We're going to plug 1 in here. And so y is going to be -2 plus 8 minus 10. So it's -4. I'm asking you not to pack up. I shouldn't hear anything chicken right now, guys. We're almost done. Brooklyn? So now we have 1 point here. 1, -4. So over 1 down to 1, 2, 3, 4. And now we mirror that point. This is 1 to the left, this is 1 to the right. And then we sketch the parabola. That's it, we're done. Remember, I'll do one of your other homework problems on the video. It will only take us 5 minutes when I'm not trying to walk you through quite so specifically. So that'll be only 3 problems you have to do if you watch the video for one of the others. Okay? Bye, guys. See you tomorrow.